Welcome to Xamarin University. Today we're going to be talking about touch in Android. This course will show you how to subscribe to touch events and work with event data in Android. We're going to split the discussion into single touch and multi-touch. We'll do single first so that we can see the core ideas on their own before we add in the extra complexity of multi-touch. We'll also go through a few general design guidelines for creating UI for touchscreen devices. We'll start out with single touch interactions. So we're going to start with a general discussion of touch-based UI. And then we're going to look at the physical user interactions, things like down, move, and up. Then we'll see how these map to notifications in your code. Next, we'll look at the ways that you can be notified as the user interacts with the screen. The most common way for C# developers is an event. However, there are a few other options as well. Finally, we'll talk about what data Android sends to you in a touch notification. When touch is used correctly, the user experience is natural and intuitive. And a big part of that is allowing the user to interact directly with the content on the screen. One theory is that users find touch UIs intuitive because it's similar to how they interact with the physical world. In other words, it's an interaction model that they are familiar with from daily life. Now, the placement and the size of UI elements is critical to make your touch UI easy to use. You should consider how your items are positioned in both portrait and landscape orientations. In portrait mode, users tend to hold small devices with one hand. One of the lower corners will be easily reachable using their thumb, and then they have the other hand free to reach the other parts of the screen. In landscape mode, users tend to use both hands to hold the device. Both of the lower corners are reachable, but they don't have a free hand to reach the other parts of the screen. So you should think about the sizing and the placement of touchable items. Remember, fingers provide very low precision. It's not a mouse with a single pixel pointer area. You should use a minimum width and height of 48 density independent pixels for your touchable items. If this isn't possible, you can often get away with reducing one dimension as long as you increase the other. You should also leave at least 8 density independent pixels between views. This is a minimum value. You should use more if space permits. And remember, people often have different size hands, so what works for you might not work for everyone. You should also keep in mind different abilities. Children have not quite as good fine motor skills, and some people also, as they get older, have trouble reaching small touch points. Now, Google does provide guidelines to help you decide on layout and element sizing. The UI techniques that you use for desktop applications often don't translate well to mobile. So you should definitely think about touch versus using a mouse. Now, we've talked about some of these things already, but remember that modern touchscreens can work with multiple touch points as well, instead of just a single mouse cursor. And in some cases can completely change the way that the user interacts with your application. Now, most of the standard views, things like buttons and entry boxes, have already been designed to work with touch. All right, so the button tells you when it's been tapped, the list view reports when an item was touched, the edit text reports when its text changes. These views and their associated events usually give you enough interactivity to build most apps. There are some cases where you need more information and control than simply receiving a click notification, however. Entertainment apps are most likely to need this level of control. So for example, suppose you're building a drawing app like we see on the right. The standard views like button, text view, list view, image view, they won't help you with the drawing. You'll need to access the low-level touch events. The remainder of this course discusses those low-level touch events. There are 3 core activities that a user does when interacting with a touchscreen. First, they make contact with the screen. Then they slide their fingers across the screen, and then they lift the finger off the screen. Android uses the term action to describe these activities, so down, move, and up are all actions. You can think of touch notifications as a sequence or a stream of messages that Android sends to your app. Each interaction follows a standard pattern. The user touches the screen, and you're notified that the down action occurred. The user moves their finger along the screen, and your app will receive a bunch of move actions. The user lifts their finger, and your app is notified of an up action. Actions are listed in the MotionEventActions enumeration. For single touch, we use the 3 core enumeration values: down, move, and up. Android sends you the stream of down, move, and up notifications all through the same channel. So for example, if you choose to be notified through an event, you will subscribe to a single event that gets raised for all of these actions. You'll be passed a down, move, or up enumeration value so that you can determine which action occurred. You have 3 options for how you get notified of these touch actions. We have a C# style event, a Java style listener, or a virtual method to override. Notice that all of these are coming from the base view class, which means they apply to most of the elements that make up your UI. So for example, you can subscribe to the touch event on an image view or on any of the layout panels. The event and the listener options serve the same purpose. They let an external client get notified of touch actions on a view. The virtual method is a little bit different. It's only useful if you write your own subclass of the view. When you subscribe to a simple event like a button click, you don't generally need any extra information. Knowing which button was clicked is usually enough. That's often not true with a low-level physical events like touch. With a touch event, you want to know more details about the user's interaction with the screen. Well, the MotionEvent class provides all of these details. You get an instance passed to you in all 3 notification techniques. The MotionEvent class contains a large variety of information. The 2 most used values are going to be the action, so whether it is a down, a move, or an up, and the coordinates of where the touch occurred. C# delegates follow a standard convention. The first argument is an object. The second argument is a subclass of eventArgs. The return type is void. To conform with this pattern, the delegate generated by Xamarin Android has a second argument of type view.touchEventArgs, which is derived from the eventArgs base class. Inside this is a property named event, which is the actual MotionEvent object containing the event details. The other 2 notification techniques, the listener and the overridable method, are not bound by this convention, so they receive the MotionEvent object directly without an eventArgs derived wrapper class. Remember that there is one event called touch that reports all of the actions: down, move, and up. In your handler, you'll need to determine what happened. Did the user just contact the screen? Did they move an existing contact? Did they lift their finger off the screen? You use the action masked property of the motion event to determine the action. It's a MotionEventActions enumeration, so it's common to switch on the value. Now there's another property that at first looks tempting. It's called action, so its name indicates that it contains the user action. However, it has multiple values packed inside it. To isolate the action, you have to apply a bit mask. That's kind of inconvenient, so it's more common to use the action masked property. The name action masked indicates that it already has the bit mask applied. And note that the action also contains the ActionIndex, which is also known as the PointerUp. So the motion event contains the XY coordinates of the touch action. You use the getX and getY methods to get the coordinates. They return the position in device-independent pixels. The coordinates are relative to the top left corner of the view. So for example, suppose you have several image views in your UI, and you subscribe to the touch event on every one of them. The coordinates that you receive will be relative to the top left corner of the image that the user touched. Let's do a quick example to see how touch events could be used in a drawing app. Suppose you wanted to let the user draw on the screen with their finger. You would need to use the touch events and create a line programmatically. Let's talk about this conceptually. So what would you do on the down action? Well, when the user first touches the screen, you want to begin a new line. And then what would you do on the move action? Well, as the user moves their finger across the screen, you need to use the X and Y points to add a segment to the line. And then on the up action, you may or may not need to do any work. It depends on how you code things. So for example, you could save the line when it's complete and then start over with a new one if the user touches the screen again. Android's path class can hold multiple lines, so it's also possible to continue with the same object as the user creates more lines. You can use Android's path class to store lines. Now, the path class is large and is complex, but you can think of it as a collection of lines and curves. Notice that this means a single path object can hold multiple lines. You won't need the full power of the path class here since we're only drawing lines. But a path maintains the idea of a current point internally. This is the location where the current geometric object ends. When you incorporate new points into a path, both the current point and the new point get used. And there's two methods that you'll need to use. Move2 sets the current point to the x and y values, but it doesn't do any drawing. Line2 draws a line between the current point and then a new point, and then it replaces the old current point with the new point. First, you're going to create a path object. You only need one since it can hold multiple lines. Of course, this is personal preference, and you could also create a new path object for each line. And then you handle the touch events. You only need to respond to the down and the move. On the down, you call the move2 method, which effectively starts a new line. Remember that move2 updates the current point inside the path, but it doesn't do any drawing. And then on the move, you're going to call line2 to add a new line segment to the path. Also, note that this code doesn't display the path in the UI. You would need to draw the path into a canvas and then add that canvas to your UI to do that. And in fact, you're going to do that on this first exercise. Go to the worksheet that's contained in this lab, and you're going to create a drawing app using single touch. Pause this video and then come back when you're complete. So there we looked at the core ideas in Android Touch. All of the touch actions like down, move, and up are sent through a single notification mechanism. For example, there's a single touch event, not separate down, move, and up events. Now we're going to look at responding to multi-touch events, where the user may have multiple fingers in contact with the screen at the same time. Now, multi-touch adds a lot of complexity. Part of that complexity is natural because there's more data coming in for you to sort through. But part of that complexity is also due to Android's history. The multi-touch APIs were added later, and they don't integrate perfectly with the single-touch APIs. And there are some important differences when supporting multi-touch versus single-touch. The down and the up actions are split into two cases. There's first finger down and last finger up. Those are reported just like before. However, the other touches are reported using different enumeration values for their actions. This creates some asymmetries in your code that can be awkward to deal with. You'll also need to process a lot more data. Your app will receive values from each contact point, and you'll have to work through it all. The tricky part is matching each X and Y point to the finger that it came from. So for example, if you want to let the user draw multiple lines at once, you'll have multiple path objects, and you'll need to match each new point to the correct path object. Most Android touchscreens support multiple simultaneous touch points. The number of supported touch points is decided by the manufacturer, and it varies from device to device. Android supports multiple input devices as well. Touchscreen devices let you use fingers or a stylus. You can connect an external mouse through Bluetooth. And some devices add support for a digitizer and a stylus with features like pressure sensitivity. Now, Android uses the term pointer to mean a finger, a mouse, or a stylus. It's a generic term that covers all of the options. Each time a finger contacts the screen, it's assigned a unique integer ID. This ID remains unchanged across all of the touch events: the down, the sequence of moves, and then the up. So here, the first finger makes contact, and it's assigned an ID of 0. This continues for the next two fingers, which get IDs of 1 and 2. The IDs that we use here in this example are what you would probably typically see. However, the assignment algorithm isn't actually documented. The pointer ID is included in the event data that you receive. It lets you determine which finger generated a given X and Y contact point. Android makes a distinction between the primary, the first touch, and the non-primary, which is all the subsequent interactions with the screen. Android uses different actions for these middle touches than it does for the first down and the last up. This means you typically end up with 5 cases to handle. There's 2 cases for down, for the first finger down, and then 1 for the other fingers. And then there's 2 cases for up, one for the last finger up and one for the other fingers. And then there's one case for move. Now the touch APIs were created in two parts. Single touch came first, with multi-touch added later. This could help explain why they feel like they're not completely uniform. For first finger down, Android still uses the same down action that we discussed before. And then for last finger up, we still get the same up action. The action for the touches between down and up have new enumeration values. There's pointer down, which indicates a new finger's made contact with the screen. There must already be at least one other contact on the screen at this point for us to receive the pointer down as the action. And then pointer up indicates that you have multiple contacts currently on the screen and then one of them leaves. It doesn't matter which one leaves, the key thing is that there's at least one contact remaining afterwards. When you're writing multi-touch enabled applications, you'll need to respond to 5 values from the MotionEventActions. In the case of down, that means handling both down and pointer down. Similarly, you'll need to handle both pointer up and up. The sequence of reported actions for multi-touch contains this asymmetry. Down and up are reported individually for each finger, while moves are batched. In other words, you will not get individual move events for each finger. You'll get one move event containing the updated coordinates for all of the fingers currently touching the screen. The Android documentation says that this batching of moves is done for efficiency. The sequence would be something like this. You start with no fingers on the screen. When the first finger contacts the screen, you get a down action. When the second finger contacts the screen, you get a pointer down action. When either finger moves, you get a move action. The event args will contain the new coordinates for all of the fingers. When one of the two fingers leaves the screen, you get a pointer up action. When the last finger contacts the screen, leaves the screen, you get an up action. Because the move actions are batched, it could happen that some of the pointers might not have changed position since the last move event. If you need to detect this case, it's your responsibility to store the previous positions and then do the comparison yourself. The MotionEvent object has an integer property called pointer count that tells you the number of active touches. Later on, we'll see how we can use pointer count to retrieve all of the x and y coordinates during a move operation. Now let's move on to our second exercise. Return to the worksheet for this lab and continue adding MotionEventActions and add multi-touch to our application. Android maintains information for each finger currently in contact with the screen. For each finger, it tracks the pointer ID, the x and y coordinates, the stylus pressure, etc. You can think of the records as if they're stored in an array. Technically, Android makes no claims about the data structure that it uses internally. However, it behaves as if it is an array, so that's the way we're going to talk about it here. The collection is 0-based, so the valid indices are 0 through pointer count minus 1. When a new finger contacts the screen, a new record is created and added to the collection. Technically, the Android documentation says that the order in which individual pointers appear within a motion event is undefined. In practice, the new records seem to be added at the end. When a user lifts a finger off the screen, Android notifies you first, then removes the record for that contact. After the record is removed, the collection is compacted so that there's no gaps. The Android documentation again says the order in which the individual pointers appear is undefined, so the compaction algorithm is implementation specific. The implementation could use an array, a linked list, whatever. Notice how the record for a finger may not stay at the same index throughout its life cycle. This is completely normal and expected. The index and the pointer ID might start out the same since they're both typically assigned starting at 0. However, they often get out of sync as fingers contact and leave the screen. Now, a MotionEvent object contains data for all of the current screen contacts. To read data out of the collection, you use the MotionEvent's get methods that take an index. For example, calling getX and passing a 2 gives you the x coordinate of the finger at the third position in the collection. Android calls the parameter the pointer index, which makes sense because it's an index into the data structure holding information about all the active pointers. Notice how the pointer ID is not always a valid index. so you should never use the pointer ID as the parameter to the get methods. Many of the get methods have an overload that take no arguments. These return values from the first record in the collection. Remember that there are 4 actions you use to track the down and the up events, 2 for the primary and 2 for the non-primary. When a finger contacts or leaves the screen, it's common to need to do some work. For example, a drawing app will start a new line when a finger touches the screen and end the line when the finger leaves. To do this work, you may need to pull data like the pointer ID or the coordinates out of the collection. Now, please think for a moment about how you might determine which element contains the information you need. In other words, which element has the data for the finger that just contacted or left the screen? Well, in 2 cases, it's easy to know. In 2 cases, you can't figure it out on your own, so Android tells you. We'll go through those cases next. The down and the up actions report first finger down and last finger up. When these actions occur, the data for the finger will always be at index 0. To see this, let's start by assuming that there are currently no fingers touching the screen. The behind-the-scenes data structure that holds info about each finger must therefore be empty. Now suppose the first finger touches the screen. A new record is created and added to the data structure. The new record must be at index 0 because it's the only one there. And then, suppose there's only one finger on the screen. There must only be one record in the data structure, so its index will be 0. When it leaves the screen, you'll receive an up action. The data for that finger will still be at index 0 because Android won't delete the record until you finish processing the up event. The pointer down and the pointer up actions report non-primary fingers contacting or leaving the screen. In both of these cases, it just isn't possible for you to know the location in the collection for that finger that just changed state. That's what the action index is for. It gives you the index of the record for the finger that just contacted or left the screen. The documentation says that ActionIndex is valid during the pointer down and the pointer up methods. There's no indication of what its value is during other actions like down, up, and move. In practice, the ActionIndex tends to be 0 for the down and the up actions. However, the Android documentation doesn't guarantee that, so you shouldn't rely on it. Pointer down gets reported when there are already some fingers on the screen and a new one is added. When the new finger touches the screen, a new record is created for it and added to the data structure. Remember that Android doesn't give any guarantees about where the new record will be added. That's what the action index is for. It tells you where the new record was added. In practice, the new record tends to get added at the end, but again, that's not guaranteed. The pointer up is reported when there are 2 or more fingers on the screen and then one of them leaves. There's no way the app could guess which finger the user removed. That's what the action index is for. It tells you the index of the record for the finger that just left the screen. Note that the record won't be removed until after your event handler finishes. Now, multi-touch events would be useful in a drawing app. You could let the user draw several lines simultaneously. When the first finger contacts the screen, you need to start a new line. When each additional finger contacts the screen, you need to start a new line for each of them too. Notice that this means you'll need to handle both the down and the pointer down actions. On the move actions, you need to add a new point to each of the current lines. Remember, the moves are batched, so you get one move notification even though all the fingers might have moved. You need to loop through all of the active records and add the point to the corresponding line. When a non-primary finger leaves the screen, you need to stop adding points to the corresponding line. And then when the primary finger leaves the screen, you need to stop adding points to the last remaining line. Notice that this means you need to handle both the pointer up and the up actions. Well, a convenient way to support multiple simultaneous lines is to use a separate path object for each line. As each finger contacts the screen, you create a new path object for that finger. Remember that each finger is identified by a pointer ID. You can use this to associate the finger with a path object. An easy way to do this is with a dictionary that uses the pointer ID as the key. The code for the down and the pointer down actions is similar. Create a new path object and add it to the dictionary. The two only differ in how they access the event data. The down action uses a hard-coded index of 0, while the pointer down action needs to use the action index. When you receive a move action, you have to process multiple new points, one for each finger that's currently touching the screen. The core operation is a loop through the records for all of the current fingers. For each finger, you look up the pointer ID and the X and Y position. Once you have the pointer ID, you use that to look up the matching path in your dictionary. Then you add the point to that path. For the pointer up and the up actions, you retrieve the pointer ID and use it to remove the corresponding path from your dictionary. The code for the pointer up and the up actions is similar. They only differ in how they access the event data. Again, the pointer up action needs to use the action index, while the up action uses a hard-coded index of 0. Now, go back to your worksheet. Let's work on the next exercise, and we're going to create a multi-touch drawing application. Again, pause this video and return when you've completed that code. The multi-touch events have a few concepts that are tricky at first. Down and up each have two separate actions. In the down and up actions, you use an index of 0 to find the data, while in the pointer down and the pointer up actions, you use ActionIndex to find the data. And then the move actions are batched for efficiency, so you need to loop to process all of the data. If you're working on a drawing app or a game, the learning curve is likely worthwhile because users will expect your app to support multi-touch. Thank you for watching this video on Touch and Android.